Hello students, welcome to the next session of graph theory. In the last lecture we have done with the definition of a graph and different types of graph. In this lecture we will cover degree of a vertex. See, what is degree of a vertex? First we will study for the undirected graph, then later on we will study for the directed graph also. It is the number of edges incident with it, except that a loop at a vertex contributes twice to the degree of that vertex, and it is denoted by DEGV. That means degree of that particular vertex, that is V. See the example here. What are the degrees of vertices in the graphs? Number one graph is G, second graph is H. See, A, two edges are there. So degree of A vertex is 2. Degree of B vertex is 1, 2, 3, 4. So that means degree of this vertex is 4. Degree of C is also 4. Degree of F is also 4. 1, 2, 3, 4. And degree of D is only 1. This one edge is there. Degree of E is 3 and degree of G is 0. Same here, we can calculate it for the next graph, that is H. So next is neighborhood of a graph. Neighborhood, or we can say that neighbor set of a vertex V in a undirected graph. It is denoted by n of that particular vertex. It is the set of vertices adjacent to V. See the example here. So A, adjacent vertices of A are B and F. So neighborhood of A is B comma F. We can write out in the form of set. So neighborhood of B is A, F and C and E. See here A, C, F, E. You can write out in any sequence. E. Neighborhood of C is B, F, E and D. And neighborhood of G is the empty set. Same way we can calculate it for the other nodes or the vertices. See, what is isolated vertex? A vertex with a 0 degree. That is, a vertex is not an end point of any edge. See, this vertex is there. This is of how much degree? 0 degree. So in this case, what is the isolated vertex? That is Z. In this case, there is no such isolated vertex. See, next is pendant vertex. A leaf vertex or pendant vertex is a vertex with degree 1. So see here 1 is the node which is having the degree only 1. This one is the edge. So that's why this one vertex is also called it as pendant vertex. Next is handshaking theorem. In this, we have a graph G which consists of two things V and E, be an undirected graph with E edges. So the formula is twice of E is equals to summation of all vertices, means summation of every vertex degree. Now see the example. How many edges are there in a graph with 10 vertices, each of degree how much? 6. So see the formula. I hope you remember this formula. Twice of E is equals to summation of every vertex degree. So 6 into how much vertices? 10 vertices, and that is equals to 60. So twice of E is equals to 60. So what is the value of E here? 30. So that means how many edges are there? Only 30 edges are in this graph. That means next is for the directed graph, in which we are having two type of degree, that is in degree. One is in degree and second is out degree. So in degree means incoming edges on that particular vertex. Out degree means outgoing edges from that particular vertex. See the example here. We have A. On A, how many incoming edges are there? But what is in the case of loop? if a node contains a loop. So in the case of loop, in the case of undirected graph, the degree of that particular vertex is 2. But in case of directed graph, 1 will be counted it for the directed and 2 will be counted it, means we can say that for the directed graph 1 will be added to the in degree and 1 will be added to the out degree. So see the degree of this particular vertex, that is A. Degree of A is 1 for the self loop and this one edge is incoming edge. So degree of A vertex is how much? 2. So here are the degree and we can denote the in degree minus A. Next, degree of in degree of B. So what is the in degree of B? Incoming edges we are saying 1. This is incoming edges 2. I think so, only 2. So degree of B is 2. Degree of C is 1 for the self loop. Second is this one and third one is this one. So degree of C is how much? 3. Same way we can calculate the in degree for the other nodes. Out degree of G, we can say that outgoing edges for the A, we can say 1 for the self loop, 2, 3 and here is 4. Same way we can calculate it for the other nodes. Now see the formula here. Let G VE means G is a graph which contains two things, vertices and edges with directed edges. Now formula is summation of all in degrees, summation of all out degrees is equals to the number of edges. We can see in the previous example. So first add all the in degrees, then add all the out degrees, then that thing is equals to the number of edges. So we will see here. So add it 2 plus 2 4 plus 3 7, 7 plus 2 9, 9 plus 3 12. So sum of this is 12 here. And in this case degree of A, out degree of A is 4 plus 1 5 plus 2 7, 7 plus 2 9, 9 plus 3 12. So this is also 12. Summation of both the degrees is equals to 12. So that means in this graph total number of edges is how much? 12. So we will count it 1 2 3 4 5 6 7 8 9 10 11 12. So that means this formula gets proved with this example. Thank you very much. In the next lecture, we will study complete graph, regular graph, cycle, wheel.